Now when you're solving problems in chapter 10 and you see the word and or in the event that you're trying to figure out the probability for. So for example, if you have to figure out the probability of A and B, then go in this direction and follow the logic diagram. So basically I'm going to call this an AND problem. So if you see an AND between two events A and B, the question you'll have to first answer is, are the events A and B independent? If the answer is yes, then you have to use this formula. If the answer is no, you have to use this formula. We've discussed the definition of events being independent. Two events are said to be independent if the occurrence of one event does not change the probability of occurrence of the other event. In that case, you would call them independent events. And if we have to figure out the probability of A and B, then you simply multiply the probability of A with the probability of B. So the word AND goes with a rule that involves multiplication, but it's direct multiplication of probabilities for independent events. Now, suppose you were looking at the events A and B, and you decided that the occurrence of B changes the probability of occurrence of A, in which case you're saying that the two events A and B are not independent. If the two events are not independent, then you need to use this formula for calculation of probabilities. So basically, you're trying to figure out the probability of A and B. So just like before, you go probability of A times the probability of B. Do you see that so far what we see that is that there's no difference? But now when we calculate the probability of B, we have to consider that A happened. So that's what makes it a conditional probability. You can't just calculate the probability independently of A. You'll have to consider that A happened and factor that in to your calculations of probability of B. And that is for events that are not independent. Now, what if we are reading the problem in probability and it happens to be an OR problem, which means we're trying to calculate the probability of A or B. So in this case, we have to go to the right and think through a different logic diagram. So the first question we'll have to answer is, are the events A and B disjoint? We've discussed disjointness in chapter 9. Two events A and B are disjoint if there is no overlap, which means the two events A and B cannot occur at the same time. If B happens, that excludes the happening of A, which means A and B cannot happen together at the same time. In that case, the probability of A or B is a simple addition of probability of A and the probability of B. Now, if you're asking yourself, are A and B disjoint, and your answer is no, which means there is an overlap, in that case, you'd have to go probability of A or B is the probability of A plus the probability of B, and notice there's nothing different so far. But when you calculate the probability of A, you're calculating the probability of the overlap within this probability of A. And when you calculate the probability of B again, you're calculating the probability of the overlap again within B. So we've calculated the probability of the overlap twice, and that's what we need to take care of. And subtracting off the probability of the overlap takes care of that double counting that we did. So that's the reason why the second formula works for events A and B that are not disjoint. Now let's look at this formula or rule. Probability of A and B is equal to probability of A times the probability of B given that A happened. Now, what if we had to find the probability of B given that A happened? We had to find that particular probability. Then what we need to do in this rule is solve for probability of B given A. So we need to solve for this. Now these are just numbers. So I divide both sides by probability of A so that cancels the probability of A, and what I've done is solved for probability of B given A. So probability of B given that A happened is equal to, now that these two are cancelled, it is probability of A and B divided by probability of A. So this is the formula that you'll have to use if you have to find the probability of a conditional B given A. Now what if I had to find the probability of, let's say, C given D? So it doesn't matter if I change the letters, I should be able to follow the exact same pattern that I see here and figure out the formula. So look at the pattern here. If the two events are B and A, the numerator of the rule that is going to give us the conditional probability is probability of A and B happening. That is, both happening together. So in this case, it would be probability of C and D both happening. So C and D divided by probability, in this case, of the second event is in the denominator. Here the second event is D, so that would be probability of D. So don't learn it as a rule, but more like a pattern that you can use for any two events, A and B, not necessarily using those letters. Now what if I had to figure out probability of, let's use different letters, Z given X or something like that. So let's follow the same pattern. We know that it has a numerator and a denominator, so I'm going to put that line here, the division line. In the numerator, it's probability of both. So probability of both would be probability of Z and X happening together divided by the probability of the second, which is probability of X. Once you get used to the pattern, you don't really have to memorize the formula. All you have to do is think about what the numerator has, which would be both, and the denominator is probability of the second event always. So this is, the numerator has both, probability of both.